Evan from Norway has asked me to do another U substitution problem, and I like these because it gets my momentum going for doing other things that maybe take a little bit more preparation. And the problem he sent me, and I hope I pronounced his name right, was the indefinite integral of sine of x over the cosine of x squared dx. This could also be written as, let's see, he wrote it in an email, so I don't know how he exactly saw it, but it could also be written as sine of x over cosine squared of x. Sometimes it's written like that. Either way, I like looking at this bit better. It's a little bit less ambiguous. But in general, you know to do U substitution or integration by substitution when you see something and you see its derivative sitting there. Right? You're like, wow, if this cosine of x was just an x, or if it was just a u, this would be a really easy integral to do. And we know how to do this integral. Let me do it on the side. This integral would be easy. 1 over x squared dx. We know how to do that. That would just be the antiderivative of x squared. This is the same thing as the antiderivative of x to the minus 2 dx. And we know how to take the antiderivative of something like that. You increase the exponent by 1, and then you multiply by what your new exponent is. Right? So it would be minus x. I'm sorry. You increase your exponent by 1, and then you divide by whatever your new exponent is. So it would be, let me do the increasing the exponent. X to the minus 2, you increase the exponent, you get x to the minus 1. And then when you divide this by minus 1, you get this minus out front. And then, of course, you would have the plus c. And if you don't believe it, take the derivative. Negative 1 times minus 1, that's a positive. And then you decrease the exponent by 1, you get x to the minus 2. So if we could get it in a form that looks like this, we'd be all set. And you kind of do see a pattern. Where this x is, you have a cosine there. And then we have cosine's derivative there. So that's the big clue that we should be using U substitution. So let's do that. And what we're going to do is we're going to substitute u for cosine of x. So if we say u is equal to cosine of x, and let's take the derivative of u with respect to x. So du dx is equal to what? What's the derivative of cosine of x? It's not quite sine of x, right? It's minus sine of x. Minus sine of x. And then we can multiply both sides by dx, and you get du is equal to minus sine of x dx. I just multiplied both sides by dx. And then if we up here we have sine of x dx, we don't have minus sine of x dx, right? There we have sine of x dx. I mean, we could have rewritten this top integral as, we could have rewritten it like this. Sine of x dx, all of that over cosine of x squared, right? So if we want to substitute for this, here we have a minus. Let's multiply both sides of this by a negative 1. And you get minus du is equal to sine of x dx. And let's see, we know, so let's rewrite this original problem now. I know I'm running out of space. Let me rewrite it. So we know that u is equal to cosine of x, so let's do that. So now this integral becomes, in the denominator, instead of cosine of x squared, u is cosine of x. That's u, right? We made that definition. So that's over u squared, right? Cosine of x becomes u. And then sine of x dx, sine of x dx, right up there, what is that equal to? Well, we just solved for it here. That's equal to minus du. Sine of x dx is equal to minus du. So that we can replace with this, minus du. And then, of course, this has the exact same form as this thing right here. You could rewrite this. This is equal to 1 over, or let's say minus 1 over u squared du. Or we could rewrite this. I'm just writing it a bunch of different ways. Whatever is easier for you to conceptualize. The same thing as minus u to the minus 2 du. And then here, we do the same thing we did up here, although now we have a minus out front. That actually makes it a little bit cleaner. To take the antiderivative, we raise u, it was to the minus 2 power. Let's raise it to 1 power higher than that. So minus 2 plus 1 is minus 1, right? So it's u to the minus 1 power, and then you want to divide by minus 1. And I'll do it explicitly here. Minus 1. And then you had this negative that was sitting out there before. You had this negative, so that negative is still going to be there. And of course, you're going to have a plus c. And you could view this as a negative, this is a -1, or this negative divided by a negative, they're going to cancel out. And so you're just left with u to the -1 plus c, or 1 over u plus c is the antiderivative. Oh, sorry, we're not done yet. That's just the antiderivative of this. And now we had our substitution to deal with. What was our substitution that we started with? U is equal to cosine of x. So if u is equal to cosine of x, this thing is equal to 1 over cosine of x plus c, is equal to the antiderivative of our original problem, which was, I'll do it in green, sine of x over cosine of x squared dx. There you go. See you in the next video.